So now we'll discuss composing multi-step workflows. So let us first understand why do we need multi-step task handling? What is the need for multi-step task handling? So most real-world tasks, they are not single step. Rather, they involve multi-step task handling. For example, if we consider the task of refund a damaged product, like let us suppose we ordered a product, we got a damaged product. Now we have to refund it. We have to return it back and get the payment back for that particular product. So if we talk about this real world task of refund a damaged product, it is not a single step task. Rather, this particular task, it involves multi-step. Like first, we have to understand the request. Then we have to validate the order. We have to check whether that order exists or not. We have to validate the order. Then we have to check the return policy. Is that product is eligible for return? Like the duration 30 days, 15 days. So return policy. And if the product falls in the return policy, then we have to call the refund API and confirm it to the user. So this real world task of refund a damaged product, it involves so many steps. So it is a multi-step task. So this example, it clearly highlights why a single prompt, like why a single large language model response is not enough. So it's not a single step task. So if we look at the complexity of this task, so a single prompt cannot know if a user is lying or if the warehouse has the item in the stock or not. So a single prompt can't know if a user is lying because we have to validate the order. So for that, multiple prompts will be needed, like multi-step will be needed. In a single step, it is not possible for us to first validate the order and also check the inventory, whether the new product is available in the warehouse or not. So real world tasks, they are complex by nature. And there is also a dimension of safety and accuracy. Because if we break the task down, by breaking the task down, the system adds guardrails. So for example, it won't trigger a refund API unless the check policy step returns a success flag. So if the check policy step, it returns a success flag, then only the call refund API will be called. So with multi-step task, we are by default, like automatically we are adding guardrails. Like if a particular condition is met, then only execute a tool or call a API. So guardrails, and it will add it will make our agentic AI system more safe and more accurate. So with multi-step task handling, we are able to deal with the complexity. We are able to achieve safety and accuracy, and we are also able to achieve reliability. We are also able to achieve the reliability. So the idea is small specialized tasks are less likely to produce hallucinations than one massive complex prompt. So just imagine if you are trying to achieve a lot in one single step. In that scenario, that large task, that one massive task, one massive complex prompt can definitely hallucinate your large language model. It can produce errors, or it cannot like it can drift away from your goal. So small specialized steps are less likely to produce hallucination. So small specialized steps will always give us the right results. Models will not hallucinate with small specialized steps. So that's the idea. So reliability. So now it's very clear that if we talk about multi-step task handling, we will be able to deal with the complexity, safety. We can make our agentic AI system more safe and accurate, and our agentic AI system can become more reliable. So now the importance of multi-step task handling is very clear to us. Most real world tasks are by complex by nature. They cannot be handled in a single step. We do need multi-step task handling, and with multi-step task handling we also achieve safety, accuracy, and reliability. So that's the importance of multi-step task handling in agentic AI systems. So we have to break the task into small subtasks and execute those subtasks to and merge the results to get the to achieve the final goal. Now let us discuss workflow types, like the multi-step workflows, different types of multi-step workflows, the architectures. So now we will discuss different types of uh, multi-step workflows, different like architectures of it. So we can have the sequential workflows, the chain sequential workflows. So in sequential workflows, this is basically a linear path. If any link breaks, the process stops. So the sequential workflow is a linear path. Like we'll start, then step A, step B, step then end. And if any step breaks, if any links breaks, the process stops. It gets stuck. And if we talk about some use cases of sequential workflows, language translation is like a very interesting example of a sequential workflow. So language translation followed by sentiment analysis. So first we will do the language translation, then we do the sentiment analysis. This is a sequential workflow. First complete this task, then the result of the previous task give it to the next task. So language, we will first translate the language, and the translated language we will give it to the sentiment analyzer, and we'll do the sentiment analysis of it. So it's a sequential workflow, one after the another. So LLM summarizes a transcript, then the summary is passed to the tool, and that tool will create a calendar invite based on the content of it. So that is how the sequential workflow works. So sequential workflow is also dynamic in nature. So this is very important. It is not fixed or rigid, rather it is dynamic. The dynamic in that sense that in the real time it will decide what next step to be taken. It's not like it's something fixed that always a particular sequential workflow will be followed. So now it's very clear that this sequential workflow is dynamic in nature. So based on the current action, like based on the current step, the next step will be decided. So that is what the sequential workflow is. We can also have parallel workflows, the fan out. So in parallel workflows, multiple steps or multiple tasks, they will execute in the same time. So this is about speed and breadth. So the agent kicks off multiple tasks at once. So in parallel workflows, our agent will execute multiple tasks at once. So task 1, task 2, task 3, they are running simultaneously. So that's the parallel workflow. And we have a coordinator which will coordinate this task and aggregation. The result of these tasks, we will aggregate it. So the use case of parallel workflow is compare prices for flight on 5 websites. So we will visit 5 websites at the same time and we will fetch the flight price and compare it. So it is an example of a parallel workflow wherein in the same time we are visiting the 5 websites, getting the flight price and comparing it. And here aggregation plays a role which will merge the results into single report. So the results of every task is been merged into a single report by the aggregator aggregation. We can also have conditional workflows, the decision trees. So in conditional workflows, the agent acts as a router choosing a path based on the logic. So based on the logic, the path will be decided. So the agent will act like a router. If this, then that. So if user is angry, then bring the human in the loop, route to human. Else automate the troubleshooting. So this is the conditional workflow. So we are discussing an example of a customer support bot. So initially customer support bot is trying to troubleshoot a user's problem, and after every response it will check whether the user is happy or not. If the user is not satisfied, if the user is angry, it will route the control to the human. Otherwise it will continue with the automated troubleshooting. So it's an example of a conditional workflow, the decision tree. Then we can also have hierarchical workflows, the manager worker. So in hierarchical workflows, we will be having an hierarchy wherein there will be a manager who will be managing the workers. So the manager agent, so the manager agent will receive the high level goal. Manager agent receives the high level goal and delegates the specific parts. So the manager agent will receive the high level goal. It will break that goal into subtasks and delegates the specific parts, the subtask, to the workers. So the worker agents can be specialized agents like researcher, writer, editor. So this is how the hierarchical workflows they work. So the manager worker. So the idea is that the manager agent will receive the high level goal. Manager agent will break it into subtasks and it will delegate the specific parts, the subtask, to the worker agents. Now the worker agents can be the specialized agents like the researcher, writer, editor. And hierarchical workflows, they have many use cases like writing a software documentation manual. So the manager delegates technical specifications to researcher, formatting to writer, and so on. So this is the hierarchical workflows. Now in multi-step workflows, orchestration is the key concept. Orchestration enables multi-step workflows. And let us see how. The key concept, orchestration. So basically orchestration is the brain or the engine that manages multi-step workflows. Orchestration is the brain or the engine that manages the multi-step workflows. If I talk about some examples like LangGraph, True AI, AutoGen. So these are the engines, LangGraph, True AI, AutoGen. These are the brains or the engine that manages the multi-step workflows, orchestration. So orchestration ensures that state is maintained. So orchestration remembers the state. Like it remembers, it ensures that state is maintained. It remembers what happened in step 1 while performing step 4. Orchestration ensures error handling. So if let us suppose any tool fails, so the orchestrator decides whether to retry or ask the user for help. So if a tool fails, orchestrator will decide whether to retry or go for any other tool or bring human in the loop or ask clarifying questions. Error handling is being taken care by the orchestration. And orchestration ensures efficiency. Orchestration ensures the right tools is used at the right time, transforming a vague intent into a precise executable plan. So let us suppose we have a vague intent. Help me with my order. Now orchestrator will convert that vague intent into a precise executable plan. So orchestrator will refer that it will do the database lookup to get the exact details of the order the user is talking about. It will call the payment APIs, shipping service, and it will create a precise plan to transform the vague intent into a precise executable plan. Efficiency. So, orchestrator is responsible for that. Orchestration ensures the right tool is used at the right time. So now it's very clear that for like multi-step workflow, in multi-step workflow, orchestration is the key. Orchestration is the engine, the brain that manages the multi-step workflows. Orchestration ensures the state is maintained, error is handled, and orchestration ensures the efficiency. It orchestration transforms a vague intent into a precise executable plan. So orchestration transforms intent into executable workflow because orchestration takes care of planning, reasoning. So whatever intent it got, it will make a plan for it. It will make an executable workflow.